Okay, lesson 91 is product and difference indeterminate forms. So we already have two indeterminate forms we've talked about. And what are those?
0, 0, infinity over infinity.
Right. If we get 0 over 0 or infinity over infinity, those are indeterminate forms. We don't know what happens in that form, so we use L'Hopital's rule to find the limit. Okay, so we have two new indeterminate forms today. And this is more instead of a quotient form, instead of a product form. Or, well, product is the one I think of most, but I always forget the subtraction one as well. One of the indeterminate forms is 0 times infinity. And then the other indeterminate form is infinity minus infinity.
To the high school office, please. Turn the ash to the high school office. Thank you.
They just got here. That's the noise I hear in the hallway, I think. Usually when I hear noise in the hallway about this period, it's the
So it's 0
kids.
times infinity and infinity minus infinity.
Yes. Yes, that is hard to read. And you'll notice I've written over it here. In your notes, that is 0 times infinity and infinity minus infinity.
Well, in ours, they're just flat. It says like 0
They look
times
like
x and then infinity, or x minus x.
Well, if you, so are mine. See? I had written over it already. So it is supposed to be infinity minus infinity. And then over here, if you're trying to read this part, we already know 0 over 0 and infinity over infinity. Okay. Got all those forms there so you can read them? Okay. Notice it says, use the same L'Hopital's rule. Just a few new tricks. Or a few algebraic tricks, I guess. Okay, so example 1. Evaluate the limit, that is as x approaches 0, of x cosecant x. Yeah. Limit of x cosecant x.
So x,
I was just waiting for a moment.
that would be x
Just give us the look
sine
of
x, which when you plug in 0 is 0 over 0, right?
So you're kind of already skipping right ahead, but yes. Okay. If we look at it as is, okay, if you put in 0 for x, that's going to be 0, right? Cosecant of 0. Well, if you think about cosecant, that's the sine graph, right? I don't know if I want to try it, that's the sine graph. And then the parabolas are actually cosecant. Well, what's happening at 0? This is going up to infinity, isn't it? And so that is the idea of 0 times infinity. Now, this is where the algebraic trick comes in. What do we more often think about cosecant? Because you guys don't like dealing with secant, cosecant, cotangent. We saw that on the test the other day.
1 over 6, 1 over 7.
Okay, so first thing I would do is change this. Make this the limit as x approaches 0. Keep the x on top and move cosecant to the bottom to become sine x.
Hunter Vance, please report to the high school office. Hunter Vance to the high school office.
And so now what happens when we put 0 in here?
0
Sine of 0 is 0, so this is the idea of 0 over 0. So what does that allow us to use? L'Hopital's rule. So it's still going to be the limit as x approaches 0. What is the derivative of x? 1. What is the derivative of sine of x? Cosine of x. So the limit as x approaches 0 of 1 over cosine x. Well, 1 on top is 1, so we've got to make something happen here. Cosine of 0 is 1, and 1 over 1 is 1, I hope, but yes. I had to do that brief. I had to look at you. Is she joking or is she being serious here? Did she have a moment or is she just having fun? We all have those moments where random math facts become, 1 plus 1 is 1, for instance. Like,
My brother would say that we disconnected from the Wi-Fi.
okay, there we go. Okay, example 2. The limit as x approaches infinity of e to the negative x, ln x. Well, what can you already tell we need to think about? Or what's going to be the easier way to process this problem? Negative exponent. Where can we go ahead and take that negative exponent? Denominator. That's going to be your easiest bet. Okay? And so, with that in mind, the limit as x approaches infinity, we're going to keep ln x on top, and e to the negative x moves to the denominator as e to the positive x. In all honesty, I don't even think I would try and find this limit before doing that, because my brain's going to process a lot easier as a fraction than it is e to the negative x. Okay, what's going to happen when we put infinities in?
Well, we'll get ln of infinity, which I assume equals infinity, and e to the infinity, which equals infinity.
So we have the indeterminate form of infinity over infinity. Okay, well, with that in mind, good old L'Hopital. So I'm keeping my limit. Limit as x approaches infinity. What is the derivative of natural log of x? 1 over x. What's the derivative of e to the x? E to the x. Okay, I was going to say, you have two options here. You could leave it right here and plug in infinity, and you should be okay. You could also go ahead and make this a singular fraction instead of a fraction within a fraction. Both ways in my brain will get you there. Because if we plug in infinity and infinity right now, what is 1 over infinity? That's 0. And what's e to the infinity? Infinity. So you have 0 over infinity, which is 0. The other way you can think about this, Ethan mentioned keep, change, flip. And the idea would be this 1 over x, the 1 would stay on top, x would end up going down to the bottom, and this would become 1 over x e to the x. And when you have that, you end up with 1 over infinity. And same idea, that 1 over infinity is going to be approaching 0. So either way, okay? Either way, you'll get there. Okay. Do you guys have what you need here? I do have example 3 on the next page, which is what I was double checking. Didn't think there was much room to work here, but. Example 3. We're evaluating the limit as x approaches 0 of 1 over x minus 1 over sine x. Well, what happens if we put 0 in?
You get 1 over 0 minus 1 over 0, which would be 0.
Okay. Well, and officially 1 over 0 is often defined as infinity. So it actually comes up to be infinity minus infinity. Okay.
So 1 over 0 gets defined as something?
When doing, let me rephrase that. When doing limits. I shouldn't say.
I was like, wow.
I never-
Wait a minute, I know, I just,
I was like,
by your reaction, all of a sudden I was like, wait, back up. Okay. So when doing limits, 1 over 0 represents infinity. Better said there? I just totally changed math for a moment. Okay,
It's not error. Everything's changed.
okay.
It's
Now-
every number.
As this is right now, I can't use L'Hopital's. Because L'Hopital's is the derivative of the numerator over derivative of the denominator. But we're supposed to be using L'Hopital's today. So what's the plan so I can use L'Hopital's?
Looks like we gotta make it one fraction. So we
Common
gotta
denominator.
exclude Common denomination.
Ew.
It could be worse.
You're right.
Limit as x approaches 0. What is this common denominator? X times sine x.
So you get like sin x minus x over x.
Yeah. So the first fraction has x already. We have to multiply by sine x. So sine x times 1. Minus the second fraction has sine x, so we have to multiply by x. 1 times x is x. So I have the limit as x approaches 0 of sine x minus x over x sine x. Well, okay, let's check out our limit. We put 0 in on top. 0 minus 0 is going to be 0. We put 0 in on bottom. 0. So, since it's 0 over 0, now we are in a good form to use L'Hopital's. And we expected that since we had the indeterminate form to begin with, but we just still have to check. The limit as x approaches 0. What is the derivative of sine x minus x? Cosine x minus 1. What is the derivative of x sine x?
Sin x plus x cosine x. Or no, yeah, sin of x plus x.
Honestly, I haven't processed the answer, so I'm not sure. But I am hearing you guys are doing product rule, right?
Yeah.
And that we do have to do product rule because there's an x and there's a sine x, so we can take the derivative of, right? So if we take the derivative of x, that is 1. Keep the sine x. So 1 times sine x plus, now I'm going to keep the x, and the derivative of sine x is cosine x, which is very possibly what you said, but
And it,
I didn't have my brain focused on what that answer was
at
yet.
the very least, it's what I have written down.
Okay, there we go. Okay. So, let's put it in. 0, let's see, cosine of 0 is 1. 1 minus 1 is 0. Sine of 0 is 0 plus x times, or 0 times cosine of 0.
So plus 0 times 1, which is still 0.
I knew it was going to be 0 for 0. I should pull out the orange.
I did think of that as I changed my marker color. I was like, you know what? I just gave myself away. Okay, well. L'Hopital's rule again. The limit as x approaches 0. Derivative of cosine x minus 1.
Negative sin x.
Derivative of cosine x is negative sine x. Over, we'll do this one in pieces. Derivative of sine x, cosine x, plus derivative of x cosine x,
So it would be plus x minus x sin x.
very possibly. Notice he did product rule again, yes? So derivative of the x is 1, keep the cosine x. Plus, now I'm going to keep the x, and the derivative of cosine x is negative sine x. Can I change that to a minus? Not very well, I can't. Okay. Plug in 0. Unless you want to clean up that denominator of cosine x plus cosine x is 2 cosine x. But in all honesty, if we're just plugging in 0, if we have to take the derivative again, we can clean it up. If not, I wouldn't worry about it. So, on top, negative sign of 0, 0. On bottom, cosine of 0 is 1, plus cosine of 0 is 1 minus 0. So I agree, 2. 0 divided by 2 is 0. Okay. Sorry, I'm trying to read what that says. X approaches what? And I realized, I have it written over here. So, in case you can't read it like me, this does say X approaches 0 from the right is what that's supposed to say. I'm not sure that's really readable, but that's what it says in my notes. So, now, if we do this whole as X approaches 0 thing, right? 1 over 0 minus 1 over 0, infinity minus infinity. So we're going to have to somehow do L'Hopital's.
I smell another fraction.
Okay, he smells another fraction. I didn't know they smelled, but okay.
They
So-
stink.
They reek.
What kind of common denominator do you guys want?
I just did x squared root x.
And you can do that, but I think you just made life more difficult.
You can put the x in the top with like x to the negative 1/2 and just have the denominator be x, right?
Can you just have X squared?
I was going to use my common denominator as X, but not as difficult as you were making it there, I don't think. Okay, this already has a denominator of X, right? I was going to make, how do you make a square root of X become X? Multiplied by square root of X. Whatever you do to the denominator, you do to the numerator. So that way, I'm just multiplying that second fraction by square root of X over square root of X. Now, am I saying you couldn't have done this with X square root of X? No, you could. And it might not even be that much more difficult, but the limit as X approaches 0 from the right, common denominator of X. The first fraction already has the common denominator of X, so we're going to have 1 minus, we have to subtract square root of X. And I assume, I didn't even, I actually wrote a step before that out. Okay, the limit as X approaches 0 from the right of 1 minus square root of X over X. Well, what you got?
So it'd be 1 minus the square root of 0. I assume it's 0.
Yes.
So it'd be 1 minus 0.
So 1 minus 0, which is,
1 over 0.
wait, 1 minus 0 is, oh yeah, never mind. Don't ask.
And
Having moments today.
over 0.
Okay.
Now, we know that that could possibly be infinity.
And it does.
Oh, wow.
Okay. I'm not 100% sure what this graph looks like just right off the top of my head. But based on the fact we're approaching it from the right, and based on the fact there's an X in the denominator, there's an asymptote here. The fact that we're approaching it from the right means there is something that's going up and along it, and thus we're going to infinity. Okay? When you approach from the left, my guess is it goes down, and that's why we're just worried about the right. If we're approaching 0 and had to check both ways, we might have a different situation. There we go. Ethan was a little too excited to say that. Okay.
She's like, oh,
Oh, you seemed excited to say it. Okay. One more. Evaluate the limit as x approaches 0 of negative 1 over x minus cosecant x.
So we can work with secant fraction, just smush it together.
I'm processing for a moment because it's not what I've done here. I'm trying to figure out why what you're saying wouldn't work, because my brain is wanting to say it does, but it gives me a different answer.
I'm working it through, and it seems like it's doing something that it should be doing.
What is that?
You just make one fraction. So you do like negative 1 over x minus 1 over sine x. Combine it so it's like negative sine minus x over x sine x. And then just do like what we have.
And I see it, and this is where I'm struggling with. Okay, so if we look at my thoughts here, before you do any turning cosecant into sine, okay, and if we think about, okay, what's happening here? When we plug in 0, 1 over 0 is going to be the whole idea infinity. Officially, I guess you would say negative infinity. Now, cosecant, this is what I'm trying to process. Is it going to come out differently for what you're doing versus what I'm doing? So cosecant, if we think about cosecant is, it's based on sine, correct? And what does sine do? From here it goes to the right, and then from there it goes like that, right? With the idea that there is an asymptote. Officially, this doesn't say approach from the left or the right, does it? And so we've got one approaching, if we approach from the right, we're going up. If we approach from the left, we're going down. And so this is where it's kind of a question mark. This is where I'm struggling with, because if we change it to sine, I'm wondering if we have to do, because what I'm going to do is I'm going to examine it from both sides. Okay? And I'm wondering if it happens later if we do it your way.
I completed this, I think. Is it supposed to be that it doesn't exist? Or, okay.
Yeah. Is that what you ended up with eventually? Okay. So it does, okay, it does work that way. That's good to know, because I was struggling with.
Because that's where my brain jumped to, and I'd already started trying to.
Areas. And this is one of those things where obviously I could have done it either way. And I'm trying to remember in my notes, without going back and looking at the book or anything, why I didn't.
It's for lunch. Pizza.
School pizza.
Yes, but what does school pizza mean?
It's because they can't call it pizza.
Is it the square one?
I don't
That's
know.
my thought. When I think of school pizza, I think of what I grew up on, which is the square pizza.
I don't know, but they can't.
When we did pizza, it was only the rectangles. And they were a lot better back then, but. Okay. So here's what I did with this one. Is because it's doing two different things, is I broke it up and looked at it as the limit as x approaches 0 from the right. And then I also looked at the limit as x approaches 0 from the left. Now, and I think, yeah. So if we think about this in both cases, okay? Let's worry about 0 from the right. So 1 over x. Well, first of all, it's the negative of 1 over x. So negative infinity, because it'd be the negative of infinity, if you will. And I don't know, do you guys remember what the 1 over x graph looks like? 1 over x graph are your two, that's regular 1 over x. Negative 1 over x flips it, right? So when you do approaching from the right, you're going up to infinity. But it's a negative of that. Minus cosecant x. Well, what happens when we approach cosecant 0 from the right? We're going up to infinity. So negative infinity minus infinity, you're still at negative infinity. When we approach 0 from the left, well, the negative 0 from the left, the negative of 1 over x. So here's 1 over x, right? When you approach from the left, where are we going? Down. So if you will, it's the negative of negative infinity, which would be a positive infinity, minus cosecant. What about when we approach cosecant, approach 0 from the left? It's going down as well. So that's minus negative infinity again. That really ends up becoming infinity plus infinity, which is just infinity, right? But it is positive infinity as opposed to negative infinity. So my limit from the left and my limit from the right are not the same. So thus, the limit does not exist. And this is where if you have a calculator accessible, in other words, I'm thinking like, you know, AP. Sometimes you use a calculator, sometimes you can't. If they want you, think L'Hopital's or something, obviously you won't have a calculator available. But if they will allow you a calculator, depending on what the problem is, it's always good to, on a situation like this, check out the graph. And that's, okay, so the actual graph ends up with, it's basically parabolas, alternating parabolas. And so on one side you have one going up, on the other side you have one going down. So that, visualizes there. So Ethan has a question. I also need to write down a couple of whatchamacallits before I forget to, but yes.
Well, so how come this cosecant x in the problem when we were approaching 0 was a question mark, but on the first one it was infinity?
I think it's just because we didn't know if we were approaching from the right or the left. It was just approaching 0.
How do I want to explain that one? It's a valid question. Give me a moment. I need to think on that one. Let me write this down. And let me check something. Okay, what do I have here? 1 becomes 13 from 86. And 19 becomes 14 from 86. And then I have 2 from 87. 15 and 16 become 3 and 4 from 87. Does that make sense? So 1 becomes 13 from 86. 19 becomes 14 from 86. 15 and 16 becomes 3 and 4 from 87.